Hello, this is the log 1 on Newton's second law at constant speed. The objective is to understand what is the meaning of the Newton's second law when we are in the case of constant velocity motion of an object. So in this slide we have the equation from the video we have. So this equation is needed to, or this mathematical model is needed to get the final velocity with knowing the initial velocity and the net force that is exerted by the object. So if we have that F net is equal to 0, then we have that Pf is equal to B initial. Using the tracker to obtain the position data of the object used for this lab, I obtained the initial velocity of the object, which was negative 1.319 meters per second. But by observing the position data, I made the velocity calculation for each pair of position data, and I calculate the mean of all velocities, obtaining a value of negative 0.9542 meters per second. And we have the initial position of the object, that is 0.00 meters. With the Python program, I changed the parts of the Python example to establish the conditions for prediction the speed and position, stating that the net force will be equal to 0 Newton. So we have here the part of the Python program that when we set the F net force equals to the vector 0, 0, 0. So then we have, if we don't have force, then the object is at constant velocity, or we have that the object is on no motion. So then we have here the model that we need to predict the final velocity, that is function of the F net and of the time. So we have established that F net is equal to 0, and we have that the observed object that we have in the video is less than 1.2 seconds. Then for the real and predicted data, I plot these values and I obtain that the simulation data over predicts the position compared for the real data. But if we can see this graph, we can see that the real data is almost the same of the simulation data that we obtained that I obtained for the Python program. So in this part of the graph, we can see that our model is over predicting the position of the object. But if it will at the initial of the first seconds of the movement and at the final seconds of the movement. So here we have the Python program, and this is what I obtained for the script that I changed for the example. So this is the object moving to the left, and this is the graph of the position over the time. So for the what if question, when you analyze your video data in tracker, you make a choice of the orientation of the axis. So if we change, if the coordinate system is changed, so that if the right moves toward what we consider negative, and if moving to the left is considered positive, we will have the magnitude of the velocity remains the same. However, the direction changes, but always bringing the reference moving in the same direction, regardless to change the x-axis. What does it mean? Your observation can be predicted well by your computational model when you set the net force equal to 0 in your model. Is it possible for you to say how many pushes and pulls are added together to give 0 net force in the case that you observe? All we can determine is the constant force, the contact force that is exerting on the object by the surface, and that what we think in our video is when the force to move it is not considered. Once moving the object, the force that could be considered is the contact force of the surface. Thank you.